Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, Abalone age prediction using machine learning. You might know that Abalone is a sea animal that lives in a cell. It has a shiny, colorful inside. People like to eat it, and its shell is sometimes used for making jewelry. You can find images of abalone on Google by searching for abalone that you can see over here. So let's get started. As you can see, also currently a Kaggle competition is ongoing on this dataset. At the end, we will submit our submission file on Kaggle. Additionally, I have created a GUI that you can see over here. Using this GUI, we can predict the age of the abalone. Finally, we will create an API for this project using FastAPI and then upload it to the render cloud that you can see over here. So let's get started. As you can see on Kaggle, the current competition is the regression with an abalone dataset. You can read the overview section to learn more that you can see over here. As you can see here, evaluation metric for this competition. So the evaluation metric for this competition is root mean squared logarithmic error. So we are going to implement our custom function for this evaluation metric, root mean squared logarithmic error. We will discuss this further during the coding part. Let's click on this tab, data. As you can see that 3 files are provided, train.csv, test.csv, and we have to submit our submission file in this particular format. 2-column CSV file containing ID and rings column. So let's get started. I have already downloaded this dataset, train.csv and test.csv. You can do the same. Now let's jump to Jupyter Notebook. So now first, as you can see, here we have imported various libraries that are needed like pandas, numpy. From sklearn, we have imported train test plate, make underscore scorer, label encoder, linear regression, decision tree regressor, random forest regressor, gradient boosting regressor, support vector regressor, XGBoost regressor, catboost regressor, LGBM regressor, and joblib. As you can see, here we have imported different regression algorithms because as you can see, we are solving regression problem. Regression with an abalone dataset that you can see over here. That's why here we have imported different machine learning algorithms for regression that you can see over here. Now next, load train and test data. As you can see on Kaggle, train.csv and test.csv. Our dataset is available in .csv file format. That's why here we have used pd.read_csv. So this line loads dataset from a file called train.csv that we have downloaded from Kaggle and saves it as a data frame named train_df. Now this line loads data from a file called test.csv that we have downloaded from Kaggle and saves it as a data frame named test_df that you can see over here. Now next, display the first few rows of the data frame or data set. So for that, we are using head method of pandas data frame. So this command displays the first few rows by default, first 5 rows of the train_df data frame, allowing you to quickly inspect the structure and the contents of the data set that you can see over here. So this is our data set having this many features that you can see over here. And this is our target variable rings that we are going to predict. So now first, sex. This is a categorical variable indicating the gender of the abalone with possible values being male, female, or infant. Next, length. This is a continuous variable that you can see over here representing the longest measurement of the cell in millimeters. Now next, diameter. Another continuous variable representing the diameter of the cell measured perpendicular to the length in millimeters. Now next, height. Also continuous, right? This variable represents the height of the abalone cell with meat in millimeters. Next, whole weight. Again, continuous variable indicating the weight of the whole abalone in grams. Next, whole weight.1. Actually, it is sucked weight, continuous variable indicating the weight of the abalone meat in grams. Next, whole weight.2. Actually, it is viscera weight, continuous variable representing the gut weight of the abalone after blending in grams. Next, cell weight, continuous variable, right? Indicating the weight of the abalone cell after drying in grams. And this is our target variable rings. An integer representing the age of the abalone. Adding 1.5 to this value gives the age in years. But we are not adding 1.5 to this value. We are directly using it for the prediction. So our dataset contains this many features. And we are going to predict this rings. This is our target variable. Now let's check shape of our data set, our trained data set. So for that, here I have used shape attribute of pandas data frame. So shape is an attribute of pandas data frame. It returns a tuple that you can see over here containing the number of rows, and the second element represents the number of columns, 10. So our training data set contains this many rows and this many columns. And this is for our test data set. Our test data set contains this many rows and this many columns. Now next, check for the missing values. So this line of code computes the sum of missing values in each column of the train_df data frame, providing insight into the presence of the missing data in the dataset. As you can see, the output of all zeros indicates that there are no missing values in any column of the train_df data frame that you can see over here. So now next, check for the duplicated values. So this code checks for the duplicated rows in the train_df data frame. So here you can see count the number of duplicated rows, and here we are displaying number of duplicated rows. But you can see output is 0 in this case, indicating that there are no duplicate rows in the data set that you can see over here. Number of duplicated rows 0. Now next, here we are visualizing the distribution of the target variable rings that you can see over here using value counts and bar plot of pandas. You can see ring 9 is the highest among all, and the rings 8 is the second highest that you can see over here. Now next, encode categorical variables. So as you can see here in our data set, there is one column sex, and this is a categorical variable indicating the gender of the abalone, with possible values being male, female or infant, right? So here for this particular column, we are using label encoder. So this code segment encodes the variable sex into numerical labels using the label encoder from sklearn that we have already imported for our training dataset and also for our test dataset as well. So now next, split the data into features and the target variable. We have to do this, right? Because our machine learning algorithms expect training data into this particular format. So that's why here we are splitting features and the target variable. So as you can see, this code splits the dataset into features that we are storing in X and our target variable that we are storing in Y. And here we are preparing our test data set by removing ID column from our test data set, and we are assigning it to X_test. Now next, split data into training and validation sets. Validation sets, also called as test set. We are doing this to evaluate the performance of our machine learning algorithms. As you can see here, our features and target variable, we are keeping aside 20% data for testing purpose. So we are going to train our machine learning models on X-train and Y-train. We will perform prediction using X_val, and we will compare our predicted results with Y_val to evaluate the performance of our machine learning algorithms. That's why here we are using train test split. Now next, define custom RMSLE scorer. Here we have created our custom function to calculate RMSLE evaluation metric, which is given on the Kaggle. You can see here the evaluation metric for this competition is root mean squared logarithmic error. So we have implemented this function using Python that you can see over here. So that particular equation has been implemented here in Python to evaluate the performance of machine learning algorithms. As you can see, our custom root mean squared logarithmic error RMSLE scorer function with name RMSLE_scorer. So this function calculates the RMSLE between the true values and the predicted values that you can see over here. Now next, here we have used make_scorer. We need to use make_scorer to create a custom scoring function compatible with other libraries of scikit-learn. So this line of code creates a scorer named RMSLE_scorer based on our custom function, this one, RMSLE_scorer. And here you can see this particular parameter, greater underscore is underscore better, which is set to false, indicates that lower values of the scoring function are better. Now next, define models. So as you can see, we have to solve this problem as a regression problem, right? That we have already discussed. So here we have initialized 8 regression models that you can see over here. Linear regression, decision tree regressor, random forest regressor, gradient boosting regressor, support vector regressor, XGBoost regressor, CatBoost regressor, and LGBM regressor that you can see over here. Now next, track based model and its evaluation score, means its RMSLE score. So for this task, we have created this particular code to track the best model and its RMSLE score. So as you can see, we have initialized 3 variables: based underscore model, based underscore model underscore name, based underscore RMSLE. So this particular variable, based underscore model, this variable will hold the best model found during the evaluation process. Here next, based underscore model underscore name. This variable will store the name of the best model. Next, based underscore RMSLE. This variable will store the best root mean square logarithmic error score found during the evaluation process. It's initialized with a value of infinity to ensure that any RMSLE score encountered during evaluation will be considered better than this initial value. Now next, evaluate models. So you can see this loop iterates over each model in the models list, this list. So you can see each model is trained using training data set on X train and Y train, and then used to make predictions on validation data that you can see over here. Predictions using validation data. Then RMSLE score is calculated by comparing the predicted values ypred with the true values which is available inside y underscore val using the custom RMSLE scoring function that we have implemented over here, right? And here we are printing RMSLE score for each model along with the name of the model that you can see over here. Now you can see here, update best model if current model has a lower RMSLE score. So here, if the current model's RMSLE score is better, means lower than the previous recorded best RMSLE score, the current model becomes the new best model, and its name and RMSLE score are updated accordingly. Now, final step, print name of the best model. So after evaluating all models, this line prints the name of the best model that you can see over here. Our all models with RMSLE score. I have already executed this code, and you can see here, as per RMSLE score, this is the best model for this particular data set, CatBoost regressor that you can see over here with this RMSLE score that you can see over here. You can take this code from my GitHub account. Link is provided in the description of this video. In short, this code essentially evaluates multiple regression models, tracks the best performing model based on RMSLE score, and print the results that you can see over here. Now next, as you can see here, train the best performing model on full data set, means on entire data set. As you can see here, we have performed train test split just to evaluate the performance of our machine learning models. But for production, we have to train our model, our best model on entire data set. That we are doing over here. We are training our best model, CatBoost regressor, on entire data set that you can see over here. Now, as you can see here, next, save the best model using joblib. So here we are saving our best model using joblib with this particular name, best underscore model. You can use any other name as well. So here we are saving our best model. So again and again, training is not required. And we can perform prediction using this saved model. And we have saved this particular name. Now here we are performing prediction on our test data. And here you can see prepare submission file. So here we are generating a submission file for our machine learning task, specifically for submission on Kaggle. Before moving further, let's submit this file on Kaggle. As you can see, currently I am on kaggle.com. First, you have to join this competition. Then only you will see this particular button, submit prediction. Let's click on this button. Now, this is our submission file that just we have created. Now, let's drag and drop this particular file over here on Kaggle. It will take some time. We have to wait. Now, let's press this submit button. You can see over here our public score. Also, you can check leaderboard that you can see over here. Please try to improve this score by performing hyperparameter tuning. Also, you can try different machine learning models. Now, let's jump back to Jupyter Notebook. As you can see, here we have performed prediction using CSV file, using our test file provided by Kaggle. Also, we can perform single prediction using our base model that we have saved using joblib. As you can see, here we are loading our base model using joblib.load that we have saved over here using joblib.dump. And here I have prepared a data frame with the features for the prediction that you can see over here. Also, I have encoded categorical variable sex. You can see here. And now here we are performing prediction using our base model on this example data that you can see over here. And you can see predicted rings. So this way we can perform prediction on entire data using our test file and using single observation that you can see. Now next, you can see I have created GUI exactly same way as we have created for our previous projects. Let's execute this cell. As you can see over here, this is our GUI. So user can perform prediction using this GUI as well. Let's enter some dummy data. Now let's click on this predict button. You can see over here predicted number of rings that you can see. Let's press OK. From here you can clear the data and you can try for another data as well. Let's exit from this GUI by pressing this exit button that you can see. Now next, let's create API for this project, Abalone age prediction using machine learning. So let's jump to PyCharm. As you can see here, currently I am using FastAPI website. So what is FastAPI? FastAPI is a Python web framework that helps developers quickly build APIs, application program interfaces with ease and speed. It's known for its high performance, simplicity, and automatic generation of interactive API documentation. With FastAPI, developers can create robust APIs efficiently, making it a popular choice for building web applications and services. So we are going to create API for our machine learning project, Abalone age prediction using machine learning. The main purpose of creating this API is that by watching this video, you can create API for any other machine learning project. And at the end, we will deploy our API on Render Cloud. So let's get started. Let's jump to PyCharm. So first, you have to install required libraries like FastAPI. To install FastAPI in PyCharm, and here you can see in square bracket all. So this command will install FastAPI with all the dependencies. Also, we have to install CatBoost because we are using CatBoost, which is the best model for this particular dataset. As per your requirement, you have to install other libraries that are required. Now, as you can see here we have imported from FastAPI import FastAPI HTTP exception. Also, we have imported from Pydantic, we have imported base model. Also, we have imported joblib, pandas SPD, and label encoder from sklearn.preprocessing. So this particular statement is necessary modules from FastAPI. FastAPI is the main class we will use to create our API, right? And HTTP exception is used to raise exceptions for the HTTP errors. That's why here we are importing FastAPI and HTTP exception. Next is Pydantic. From Pydantic, we are importing base model. So importing base model from Pydantic, we will use it to define the structure of the input data our API expect. That's why here we are importing from Pydantic import base model. And as you know, joblib. to load our pre-trained model that we have saved earlier. And you know pandas to work with data. And also you know label encoder to encode categorical variables. In our case, sex variable only, right? And you can see here we are loading our pre-trained model, means our saved model that we have saved with this particular name, based underscore model, right? This one. Next, load train data to get feature names for input. So here we are loading the train data from a CSV file named train.csv that we have downloaded from Kaggle to get the feature names. As you can see, we have dropped ID and rings columns as they are not features used for prediction, right? So here we are extracting feature names. That's why here we are using train.csv. Next, encode sex feature. So encoding the sex feature to numerical values using label encoder. And here we are creating Python dictionary with name sex underscore encode to map numerical values back to their original categorical values. Here we are creating a FastAPI application instance named app that you can see over here. And here we are defining request body model. You can see here defining class input data inheriting from base model. This class represents the structure of the input data expected by our API endpoint that you can see over here. It includes attributes for various features of an abalone that you can see over here. Sex, length, diameter, height, whole weight, shucked weight, viscera weight, and cell weight that you can see over here. Now next, define root and point. So here we are using app.get decorator using this forward slash. So this endpoint is used to provide a welcome message when accessing the root URL. Don't you worry, I will show you shortly. Now next, define prediction endpoint. You can see here we are using app.post decorator. So this endpoint is used to receive input data and return predictions. So this prediction function takes input data of type input data representing the input data. As you can see here we are processing the input data, particularly handling the sex feature to ensure it is in the expected format that you can see over here, M, F, and I. Here we are preparing the input values needed for making prediction that you can see over here. And here we have used the pre-trained model, means our saved model, to make predictions based on the input features. And finally, here we return the predicted number of rings as the dictionary in the JSON format. And here we are handling exception using HTTP exception that you can see over here. So in summary, this code sets up a FastAPI application with a prediction endpoint predict to predict the number of rings in the abalone based on input data, and a root endpoint, this one, to provide a welcome message. That's all. Now let's run this. To run this, we have to use this command uvcon main, which is our app name. You can see here :app -- reload. Now let's click on this terminal. So to run this, we have to write uvcon main, which is our app name, :app -- reload. Let's press enter. You can see over here. Let's click on this link. You can see here welcome message. Welcome to the abalone rings prediction API. You can see over here that we have given over here in the root endpoint, this one. Now here to perform prediction, we have to use docs endpoint. So you can see here 127.0.0.1 8000 because server is currently running on our local machine. And we have to use this docs endpoint. You can see here. Now let's click on this post and you can see here. So now let's try it out our prediction. So click on this button, try it out. And here we can give different values for prediction. Let me show you this. Sex, male, length 0.335. You can give any. Diameter 0.235. Height 0.075. Whole weight 0.1585. You can give any. Shuck weight 0.0685. Viscera weight 0.0375. Cell weight 0.0450. And perform prediction, we have to press this execute button. You can see over here. Predicted number of rings. So this way we can use FastAPI to create API for our machine learning models that you can see over here. Now you can create API for any other machine learning project as well, right? Now let's deploy this API on Render Cloud. So let's jump to Render. As you can see, currently we are using dashboard.render.com. So we have to sign in to Render. So you can sign in using GitHub, GitLab, or Google. I have already signed in with my Gmail account that you can see over here. Before we start deploying our machine learning API that we have created using FastAPI on Render, first we have to prepare something. As you can see, I have created one repository on my GitHub account. You can see here, which contains joblib file, means our saved model, based_model.joblib, main.py. You can see that we have created in PyCharm, our code for API, also requirements.txt. So this is our requirement. So these libraries will be installed on Render Cloud. You can see here libraries for our FastAPI. You can see different libraries that we are needed to run our API. And also you can see CatBoost, which is also required because this is our based model, right? And also train.csv because we are extracting features name from this file, right? So you can see to deploy on the Render Cloud, we require our saved model, our code file main.py, requirements.txt, and train.csv. Now let's jump to Render Desktop. So after login, you will see this button new. So let's press to new and we have to click on web service. Now, how would you like to deploy your web service? Two options, but we are selecting build and deploy from a Git repository. Let's click next. So either you can perform search or you can select from here and let's press connect. Here you can give any name using ML. You can give any other name. Keep as it is main. This is also as it is. You can see here it will install requirements.txt. So libraries that we have mentioned in requirements.txt will be installed on this cloud. So Render can run our API and here this is required. So that we have to get from Google. So now you can see here, we have to use this command that you will get by searching on the Google deploy FastAPI app. This one. Let me copy this and let's back to Render and paste it over here. So instance type. So these are possible ways, but let's click on this free account. Now at the end, you have to press create web service. Let's click on this button. As you can see, deployment process has been started. It will take some time. You have to wait. I am going to pause this video. You can see installing collected packages. As I said, Render is installing collected packages that we have listed in requirements.txt that you can see over here. It helps Render to run API on this Render Cloud that you can see over here. Uploading build. Still we have to wait. You can see currently it is deploying. Build successful. Now done. So we have successfully deployed our API on this particular cloud Render. So after this, you can find link over here, which is public link. Let's click on this. You can see here welcome message that we have provided. You can see now again docs endpoint. You can see here exactly same as we have done in our local machine, right? Again to perform prediction, we have to click on this post and again try out. Now length, diameter. I'm entering random values just to show you the prediction by our API and mail. Let's click on this button, execute. You can see over here our prediction. So this way we can create FastAPI for our machine learning project that you can see over here. And this way we can deploy on Render Cloud that you can see over here. So anyone can access our project using this link that you can see over here. Hope you can create API for any other machine learning project, right? Using FastAPI and also try to deploy your created API on this cloud Render. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.